I could just maybe add the International Society for Stem Cell Research, of which Gordon was the president a couple of years ago, and now has a committee out that's trying to put forward recommendations for what should be considered an acceptable, what evidence would convince people that this is an acceptable type of stem cell therapy that should be offered to people. And so because there are so many fly-by-night stem cell tourism companies, I think that some of these international agencies will step up and actually try and give some guidelines for what should be considered by most people a reasonable type of therapy.
Hello. I have a follow-up on this regarding the... that was reported in the mainstream media, and one of the things that they mentioned was, for this Brazil study, was that they stopped the autoimmune attack by using chemotherapy. Is that something that is possible for in research? Being researched?
That you're referring to islet transplantation. I don't think, to my knowledge, I don't think it's stem cells. That's a little bit different. And xeno-islet transplantation means islets that are derived from another...
Actually, this study, from what the NBC report said, was that it was people that were newly diagnosed with diabetes, and they still had beta cells that were producing insulin. They then put them through chemotherapy and changed the immune system to stop the attack. Is that some research that you've heard of or see any promise in?
I can maybe address that. Actually, we'll let Dr. Ehrlich address that, since he's one of the world experts. It's very helpful to have him here. Because this really, this is not relating to stem cells.
Ontario did that with Cyclosporin about 20 years ago and showed that it transiently improved the survival of beta cells, but it ended up with kidney damage. So there isn't any long-term studies. I think somebody referred to the work that was put in W5, the TV program, had a program on it about 2 or 3 years ago where a surgeon in Mexico or Brazil was putting pig islets into tubes and curing diabetes. It was only temporary, and they all relapsed.
Yeah. So remembering that the process of pancreatic beta cell damage in the early stages of type 1 diabetes is a process of immune destruction that goes on for a few years. And so actually modulating the immune system in those early times is potentially very promising. And there have been a number of clinical trials. So far, none of them have been tremendously successful.
Okay, and if I could, I just have a quick question about how these cells, stem cells, would be transplanted. And if the immune attack continues, could you then maybe do a transplant in a person once a year, and if they regenerate?
I think that's a possibility, especially I think with the IPS and ES technology, where the cells can exist in a dish for forever, essentially. If there is an autoimmune attack, then a secondary transplant might be reasonable. In experimental animals, there's a number of places where you can put beta cells and have them function normally. They're not like cells in the brain where they have to make connections with other cells. All the beta cells have to do is sense glucose levels and release insulin in response to changes in glucose levels, and they can be situated anywhere. So in animals, people have put beta cell transplants in the kidney, in the testes, all kinds of different places, and they seem to work fine.
I'm going to take, lots of hands. I was going to say I was going to take one more question. I'll take 3 more questions, and then our scientists will be here to answer some more questions, but I know a lot of people will have to leave. Go ahead, Terry.
Let me make a comment. I ask a question and I make a comment. I want to ask a question about, so you have very exciting talks, very exciting information. So you have, let's say, an IPS, Gordon, and you transplant it. It's a differentiated cell, or it'll develop into a differentiated cell type. How long will that differentiated cell type survive and carry out its newly acquired function? Is that known for any type of IPS?
I don't think we know. I just don't think we know how long they will survive and function. And I think the exciting thing is we're on the cusp of being able to make enough of these cells to start asking those questions.
The answer from the pancreatic islet transplants from the Edmonton protocol is that they'll last several years before they eventually are attacked, presumably by autoimmune attacks. So it's conceivable that at least with whole pancreas or islet transplants, you can have several years before they're attacked.
Right. It's usually about 2 to 4 years where they retain function and then they poop out or are killed by the immune system. So being an immunologist and focusing on the autoimmune aspect, just let me bring some hope to the discussion and answer a question that was previously posed. So why do cells of the immune system search out and kill the beta cell? We all have cells that react to our own tissues, that react to our own insulin-producing beta cells, but they're held in check by another type of cell that regulates that response. They're known as a regulatory cell. So there's always a balance between the cell that's going to kill the beta cell, the killer, and the regulatory cell. In diabetics, as new information is emerging now, there is a deficiency of the regulatory cells. So the number of killer cells increase as a result and are more inclined to carry out their function. And now we're beginning to learn about some of the genes that control susceptibility to type 1 diabetes that cause a deficiency in the function of these regulatory cells. And by replacing those genes or modifying them, we can now, at least in some mouse studies, out of a report just appeared last month from a Montreal group, we can now understand on how to modify these susceptibility genes, increase regulatory function, and thereby prevent the onset of diabetes. If we can apply that to humans and to handling and recognition of stem cells, I think it's going to be a major step forward.
Thank you very much. Can you take the microphone to the gentleman at the back who's had his hand up the longest?
Thank you very much. Just from the literature about artificial reproductive technology and kind of the artificial manipulation of cells and everything and the increased risk for genomic changes that occur post those procedures, I just wondered whether anyone has looked at the manipulated stem cells to see if there have been genomic changes that potentially you could be solving one problem and cause another. So I just wondered if you could comment on that.
It's a great question. And certainly you will see genetic changes in embryonic stem cells if they're handled poorly. You will see changes in chromosome numbers. Those are easy to detect. There are other changes that are probably harder to detect, and we don't know for certain if we are changing the epigenetic makeup of the cells. And for some of these we can evaluate them. For others, we probably can't. My feeling is we probably, if we're careful, we can probably make a cell type that will function quite well in an animal and ultimately in the human being. That's my feeling, my hope. I think we have enough understanding of the genome that we can evaluate at multiple stages how many changes we've introduced and how many changes that may be harmful. That being said, it's still taking a cell, putting it in a dish, growing a lot of cells up, and putting it back into an animal or a human being.
I guess the one other hope for the IPS research is that if one cell that you take from the skin, turn into an ES-like cell, goes bad because it gains mutations, you just take another one. Right, and recreate a new IPS line from another cell in your skin. So there is the possibility, if one of those cells shows a lot of genetic changes, to try and replace it. Unfortunately, if the genetic changes have happened after you transplant it in, then you may have a problem.
I think I'm going to stop the questioning now, and I know there are still a lot of questions, and you'll be able to still ask our scientists some questions afterwards, but I'd like to just take this opportunity, and please join me in thanking Drs. van der Kooy and Keller for those excellent talks.